In this video, I'm going to be going over Chapter 5 review probability problems. So I'm going to assume that you are going to read these questions first, and then I'm going over the answers. So in this question, to fill out our chart first, we have 52 athletes. We have 26 of them to be female, and then 6 of them are swimmers. So we have 20 leftovers to be not swimmers. And then in terms of the male, we have 10 male swimmers. And then in total, to subtract 26 from 52, that is also 26. So we have 16 here. And these are the rest of the values. Okay, so in the problem it says given that the probability, or given that the individual picked is female, find the probability that she's a swimmer. So the probability that she is a swimmer, given that she is female, so this indicates we are going to have a fraction. The given part at the bottom will represent our new sample space. So our new sample space is going to focus only on females. So we're just looking at this row right here, and that gives us a total of 26 females. And then of those females, we have 6 swimmers. So these are the values we are focusing on here. For part 2, it says given the probability, or given that the individual picked is a swimmer, find the probability that he is a male. So the probability of male, given that this male is a swimmer. So here we are looking at not the males as the new sample space, but the swimmers as the new sample space. And the new sample space, our total is going to be 16, and of that 16, 10 of them are going to be our given part, or the part that we were looking for. Okay, so that's my value. We have 6 out of 26 and 10 out of 26. For our next problem, it's talking about contestants and then picking a number from 1 to 100. If it's divisible by 9 or 12, then they will win. So the first thing you want to do for a type of problem like this is just to list out the values that are divisible by 9 and 12. So I'm going to do that right now. And then this is, oh crap, my numbers are a little off right now. Okay, and then my other set of numbers are these. I think that's the last one. I think 96 the last one. So it says, what's the probability that the contestants will win? So the probability of winning is technically saying the probability of me picking a 9 or something that's divisible by 9 or divisible by 12. So notice that in this probability, we do have something that crosses over. So the number 36 occurs in both lists, and the number 72 occurs in both lists. So I can't technically just add both of the probabilities of 9 and 12, but I have to make sure that I add both those probabilities and then subtract the overlap. So I'm going to subtract that by the probability of something that's divisible by 9 and 12 at the same time. So the probability of something divisible by 9 should be 11 out of, I forgot what the value was. Oh, 11 out of 100 plus 8 out of 100. So there should be 11 values here. There should be 8 values there. And then we have 2 things that overlap. So our total here is 17 out of 100. So that's my final answer for that problem. Okay, so moving on to the next, this talks about Trevor Ariza making free throws, and his average is 71% of the time, and it doesn't change from one shot to the next. So this says, what is the probability that he missed his free throws? So I just got to make sure that if he makes it 71% of the time, the rest, which should all add up to 100, is his make. So the probability of him missing is kind of the same as doing the complement, which is 1 minus the probability that he actually makes it. And as you can see, it's the same as doing 1 minus 0.71, which equals to 0.29. Part B says what's the probability of him not making his next 5 free throws. So he's going to shoot and then he's going to miss. Okay, that's the chances of him missing, and then he's going to shoot another time and another time and another time and for the 5th time. So that's 1, 2, 3, 4, 5 times, or we simply could have just done 0.29 to the 5th power, and that's going to give me some value. So you can calculate that out on your own. That should be a simple calculation. All right, next one. Part 4 talks about somebody named Brian and Beth checking the building, and the percentages of them checking the building. So we have a 0.96, a 0.98, and they both check 0.95. So this whole idea of both represents this idea of and. So when we're doing a Venn diagram, you always want to start in the middle. The middle is going to represent when they both do something. So this whole idea of and, Brian and Beth checking the building. So this is 0.95. And when we do our Venn diagram, you simply can't just throw in the numbers as you see them, because you have to remember that in the Venn diagram, the whole entire bubble will represent one person, which is 0.96, and the whole entire bubble itself would represent the other person, which is 0.98. So notice that as I circle the bubbles, 0.95 is included in those bubbles. So I just got to see what's left over. So notice that for Brian, 0.01 is left over, and when I add those two values, it should give me 0.96, and so therefore this side should be 0.03. If I add those two numbers together, I should get Beth's side. And if I were to add all these in general, all these numbers do not add up to 1, so I'm missing something from my Venn diagram. And technically I'm not missing it inside, but I'm missing it on the outside. So inside, if I were to add these values up, I get 0.99. On the outside, I therefore get 0.01, giving me a total of 1. So what is the probability that neither Brian nor Beth checks on the weekend? So I'm going to write that out. So the probability of not Brian or not Beth, and this is just me abbreviating, which is 0.01. So that's just that. Okay, for part 5, it talks about 2 ambulance service. One is the city service and one is the private service, and this is their respective probabilities of responding, and then the probability that either of them, which is an or statement, is 0.9. So this is asking us for the probability of both, and remember from the last slide I said that represents and. So when you are given an or statement and you're looking for an and statement, then what you want to do here is use the probability, the general addition formula. So to find the probability of, let's say this part is A and this part is B, so A and B, what I have to do is I just have to add those two probabilities together and then subtract that from the probability of both happening, A or B happening in general. So now I can just plug in values. So I have A to be 0.6, B to be 0.8, and then I'm going to subtract that from 0.9 to give me my final answer. And then again, you guys can figure this out. So I'm going to move forward. In part 6, we have 2 channels, channel 7 and channel 10. And then they are affiliated with the same networks. And then they show a particular sport events, one of them 50% of the time, one of them 70% of the time, and at the same time they both carry it 0.3. So both is and they want you to find either, which is or. So again, we can use this formula, but notice that and doesn't go first. So let's say channel 7 or channel 10, and this is what I'm looking for. So I'm going to find the probability of this using this formula instead. And notice in the previous problem, or was at the very end, but now and is at the very end, which is okay because you can move this around like it's a mathematical equation, so which it is. So now I'm just going to plug in some values. So I have 0.5 plus 0.7 minus 0.3, and that should give me the final answer. Okay, next one. So here we have voters. Within the voters, we have white people, black people, Hispanic people, and of those people, there is also a percentage that indicates if they are going to vote for the mayoral candidate. So first we have to draw a tree diagram, and in the boxes we are going to indicate the races and the percentage for each. So that's what we indicated first, and then second we have to see if people are going to support or not support based on the race. Okay, so notice that 30% of white people supported our candidate, so I'm going to put 0.3, and the complement of that is 0.7, and then for the black is 0.9, so the rest is 0.1, and then we have 0.5 for both. So it says, what's the probability of the overall votes does the candidate expect to get? So in order to figure that out, we know that there is support from each race, and then we have to just highlight where that is. So I'm going to first start by highlighting where you can find the support, and then I'm going to calculate those values. So first we have white that's support, which is calculated by doing 0.4 times 0.3, so I'm just gathering that from the branches, and then I have black that's support, which is 0.4 times 0.9, and then we have Hispanic that support, which is 0.2 times 0.5, and then these values 0.12, 0.36, and then 0.1. So these are all the values, therefore the probability of gaining support, maybe I should just put support, I put vote on other ones, is equal to 0.12 plus 0.36 plus 0.1. And then if I were to add this all up, I should get 58. Yeah, I think that looks right. Yeah, 0.58. Okay, so part C, it says, if the candidate's prediction comes true, which is technically a given statement, what percent of the votes comes from black voters? So the probability of getting a black vote given that you had gained support, given that this was true, okay? So we know that the given part is our new sample space, and within our new sample space we have to look at all the people that support, which are all the highlighted people, and that percentage, which we have calculated from the previous question, is 0.58. And of those highlighted areas, so notice I didn't calculate the rest because I technically don't need it, of those, which ones were black, then this is the percentage I will have as my numerator, and then you guys can calculate that out and see how much that is. All right, question 8 is, we have 5 stocks. The probability of each of those stocks are exactly 0, 1, 2, 3, 4, or 5, and then the probability, or the probability of getting those stocks to go up are relative to the numbers above, so they should match up. And this one says, what's the probability at least one stock goes up? So the probability of at least one goes up. So to find that, it's similar to finding the probability of 1, or doing 1 minus the probability that none of the stocks go up. So as you can see, so if I were to figure out which one goes up, I can see I can do 1 stock, 2 stock, 3 stock, 4 stock, 5 stock, because at least one of these in each of these numbers go up. So might as well just calculate what is left over, which is this 0 that corresponds with 0.1. So I'm technically doing 1 minus the probability of no stock going up, which is technically 1 minus 0.1. And then you guys can calculate that. And the next one is, what is the probability that at most 4 stocks goes up? So the probability of at most 4. So if I were to look at what's the probability of at most 4, and if I were to highlight it, so I have 0, 1, 2, 3, and 4. So all of these works. Because all of this work, might as well just do 1 minus this value. So that is 1 minus 0.1, and then that should get you that answer. Hopefully I did that right. At least one, which is, oh yeah, I think this is a coincidence because it's 0.1 for each. Next one is, if you flip a coin and roll a die, what's the probability of flipping a tail and rolling at least 4? So the probability of tails and of 4. So to calculate that, you're going to actually use the multiplication rule. And you can use the multiplication rule on this because these are independent events. So if I flip a coin, the chances of me getting a tail is 1/2, and if I were to roll a die, the chances of me getting a 4 is 1/6. So if I were to multiply that, I get 1/12, and that's my value. All right, last one. A goblet contains 4 red balls, 6 green, and 10 blues. So I should be picking a red first and then a blue second. So the probability of first picking a red and second picking a blue is going to actually be a given statement. Okay, so first I'm going to try to pick a red, so I got to figure out what's the probability of picking a red. And then I'm going to multiply that by the probability of picking, oops, I didn't even put red. So first red times the probability of picking a second ball to be blue, given that my first ball was red. Okay, and if you take a look at it, if my first ball was red, the chances of picking a red should be 4 out of 20 because there are 20 balls in total. And then after I pick my red ball, I have to throw that ball away because I didn't put it back. So that means I only have 19 balls left, but I still have 10 blue balls. So there's no change in that. And then if you multiply that, that should be 40 over, I think it was 380 from what I remember. But you have to remember, if you put it back or you don't put it back, it changes the value for this term right here. Okay, so hopefully this was helpful so that you can kind of review again. All right, bye guys.